All right, so let's take a look at the back side of our lesson. All right, up here at the top, we see that a fact family is a set of 4 related multiplication and division facts that use the same 3 numbers. This is just like the fact families that you did in first, second grade. If 3 plus 7 equals 10, then 7 plus 3 equals 10. And you could subtract 10 minus 3 is 7, and 10 minus 7 is 3. So let's look at these fact families for this example 2. Example 2 says LaTanya and her father made an array of buttons. Write a fact family for the sentence. Write a fact family for the array. So here's our array of buttons. Notice they have 4 columns and 3 rows, and we have equal amounts here. All right, so this is why we call it an array. So we're going to start off with our multiplication sentence in our fact family. We're going to say 3 rows times 4 columns equals to 12 buttons. Then we're going to use the commutative property of multiplication and say that if 3 times 4 is 12, then 4 times 3 is also 12. Now that we've done our 2 multiplication sentences of our fact family, now we need to do our division. So with division, it's just like subtraction. We do need to start out with that big number first. So my product in my multiplication sentence becomes my dividend in my division sentence. So 12 divided by 3, which is one of my factors in my multiplication problem over here, equals to 4, which is my other factor. So if I look at this backwards as a multiplication sentence, 4 times 3 equals 12. So 12 divided by 3 equals 4. All right, now we have to flip not my dividend and my divisor, but my divisor and my quotient. We need to flip those around and keep my big product from over here, keep it in front. And instead of saying 12 divided by 3, we're going to say 12 divided by 4 is 3. And again, if we check it by looking at the problem backwards, 3 times 4 is 12. All right. So it should be similar to what you've learned before. So let's take a look at, this next example. Okay, so Vanessa has 36 books. So we know Vanessa's total. She has 36 books to put on 4 shelves. The same number of books will be placed on each shelf. How many books will be on each shelf? So again, we see that word each, which is signaling that we're probably going to have to multiply or divide. Now think about this. We know Vanessa's total. We know that she's taking 36 books and she's putting them on 4 shelves. So if we know the total and we're dividing up these books on each shelf, we know our numbers here aren't going to get bigger. So we know we cannot multiply and we cannot add. So now we're thinking about either subtracting or dividing. So if I have 36 books and I'm putting them into groups of 4, I've got to put books on each shelf. That means that I need to divide 36 books by 4 shelves. Now, how we solve this is we think of this backwards. I'm going to say, instead of saying 36 divided by 4, I'm going to think backwards and say, well, what times 4 will give me 36? I'm going to use an unknown right here. What times 4 will give me 36? Well, 4 times blank equals 36. We've learned that 4 times 9 is 36. So, with knowing about fact families, the number that 4 and 36 have in common is 9. So if 4 times 9 is 36, and we have our 36 and our 4, our 36 as our dividend and our 4 as our divisor, we know that the other number that's left is 9. 9 times 4 equals 36. So Vanessa will place 9 books on each shelf. All right, so let's scroll down and let's look at our 2 examples right here. Write a fact family for each array. So the first step is to count our arrays. So let's go across and up and down on our paint palette here. So 1, 2, 3, 4, 5, 6, 7. So I have 7 on top. 1, 2, 3, and remember I still have to count this corner one, 3 on the side. So now I have my 2 numbers for my fact family, and I know if I multiply them, I will find out how many colors there are in all here. So I'm going to start out with my multiplication sentence always. 7 times 3 is 21. Now I'm going to use the commutative property of multiplication, which is 3 times 7 equals 21. Now that I've done both of my multiplication sentences, I'm going to do my division. And remember, division is just like subtraction. I have to start with that big number first. So 21 divided by, and you can pick either factor, 3 equals to 7, the number that's missing right now. And then I'm going to keep my big number first again for this last division sentence and say that 21 divided by, not 3 because I used it, 21 divided by 7 equals to 3. If you wanted to double check, you could look at it backwards. 7 times 3 equals 21. 3 times 7 equals 21. All right, now let's look at number 2. Now notice on number 2, I have 1, 2, 3, 4, 5, so 5 on top. 1, 2, 3, 4, 5, 5 on the side. Don't forget to count that one for up and down and across. So my first multiplication sentence, my first number sentence, I'm going to start with multiplication in my fact family. So 5 times 5 is 25. Now you'll notice they only gave me 2 lines right here. That's because if I do the commutative property and I flip my 2 factors, if I swap these 5s, they're still going to be 5s. So there's no use to rewrite that. So now I'm going to skip straight to my division sentence. I'm going to start with that big number. I'm going to pick one of these factors, which happens to be the same. And what times 5 gives me 25? 5. Now, before we wrap up, I want to remind you, I've posted the properties of multiplication in our current classwork. You definitely need to be studying those. Right here, let's answer, how are multiplication and division related? Multiplication and division are, like addition and subtraction, they are inverse operations. And you know that inverse means opposite. So check out those properties of multiplication. Make sure you're studying vocabulary. I will send you a snapshot of those, but there's a lot of important vocabulary on what I posted for the properties of multiplication as well. So I hope this has helped. If you have any problems, please let me know. See you later.